you friends, and in this video we are going to discuss about the recursion. Recursion is a practice and this is mainly used in object oriented programming languages, or it can also use in the procedure oriented programming languages like C. Recursion, the idea of the recursion is that you might have seen that when we design a program, then it involves creation of large number of functions where the one particular function calls in other functions. You have seen that when we calculated the area and the volume of the cylinder or circle, then we used math.py, and then whenever we have to find the square root function, we simply incorporated the features from the java.lang.math package, and we simply used it and we got the square root of that particular number. So there are so many inbuilt functions, like whenever you're calling the uh, println function. So println function we are just using, we haven't designed it. So system.out.println means there is a class called system, and there is a, you can say, system.out.println. So the function in the object oriented programming languages, you have seen that a class contains function and the package contains the class. A package can have the many classes. So when you're calling a particular function, it belongs to a particular class, maybe this class, and when you are having a class, then the class definitely may be belonging to some other packages. So slowly we'll discuss about the Java packages. Now we are just trying to understand what is the recursion. Recursion means, can a function call itself? The answer is yes. A function calling itself is called as a recursion function. Now using this, I'm just trying to find out the power function, and power function, because power f, this is my class, and I just open this editor now, and here I do not need all these things, only one function will be required. So this is power, POWER. This is not English language, so you can write anything, but it should be relevant and meaningful. That's why. Now here this is a number. Whenever you are trying to find the power of a number like 2 to the power 3, then you have to pass three values, int m and int n. So the power is m to the power n, and m to the power n is nothing but if m is multiplied n number of times, then you'll get m to the power n, and finally it will become slowly 0. So m to the power 0 is 1. So we'll say if n equals 0, then return 1, and else if it is not the case, then what to do? Else return m into power function m comma n minus 1, just decrease the value by 1. So the idea, again, I want to elaborate with the help of my explanation, and that goes like this. When you have like m to the power n, means you are multiplying m into m to the power n minus 1, then this will become m into m to the power n minus 2, and slowly this number is decreasing, so this will become m to the power 0. So when m to the power 0, we know that the indices say that any number to the power 0 is 1. So here this thing becomes, when it becomes 1, when n minus 1 slowly n minus 1, n minus 2, n minus 3 becomes 0 and becomes 0, then it has returned n functions, and now this is returning. So let's compile and see how it works. So now see, this is new power function, created the object, but we don't need that object actually in a literal sense, because we can simply, oh, are there some error? Here I don't have any error. Then where are errors? Stroke class pow m dot power. Oh, this function should return. Yeah, but this is returning. Okay. So what happened? Why this gets stuck? Compile. Class power f. No constructor, nothing is there. Only I have a function called power. Is the word power confusing it? M power, if I use M power. Oh my god. Now, oh, compiled. Yes, it was some fault with the hardware, it's not the problem with the machine. So I entered here 3 to the power 5, and it's 343 something, 243. So this is working. This is called, now I introduce one more class just to explain you the sum, because sum can also be utilized using this value. How? Now see, if you just have to find the sum of 1 plus 2 plus 3 plus 4, starting, always starting from 5, here in this case 6 plus 7, like this. Suppose n is the number entered by the user. So it is just like, first you add these two, then you add these three. So sum itself is a large number of sum. So starting from the number, like the number, and then I add n minus 1 and add n minus 2, and slowly it becomes 1. So this is why this summation is getting broken down into large number of functions. So again here I remove all these things, since we are just paying attention to recursion, so it should not have. So I name it recur, and I have to find the sum starting from 1 to this number m. And if I say again same way, just m equal to 1, then return sum as 1, and else return return m plus, I'm calling the same function recur, and I'll pass 1 less. So now let's see how it works. Compiled, and I create the object, created, then I pass a number 10, because 1 to 10 we can say is 55. This is right. Yes, it is right. Again I take one more class just to give you some more illustration, and this is, I call it facto. So it's just going to find the factorial of a given number. So I remove factorial. You know that the factorial is 5 into 4 into 3 into 2 into 1. This is your 5 factorial. This is starting from the number itself, keep on multiplying till you find 1. So here I write, this name is so weird, so I call fact. Remember, because this is the function I'm going to call. And then this is my n. Then there I'll write if n equal to 0 or n equal to 1, return 1, else return n into fact n minus 1. So it's compile it, it's working. Now I create the object and I create the object, and then I pass a value. 6 is 726, factorial is 720. Here it is. So this is the idea of the recursion, a function calling itself. In the data structure of Java, it is said that when a complexity or when a problem can be broken down into the large steps, and each steps can be added together just to find the solution. Like, if another way is say, that's a very strong word, but I'm saying that, say, if a problem can be broken into the sum of the solutions, then in those situations recursion is quite handy. Thank you very much. Just subscribe to our channel and stay fit, stay ahead of others.